One thing that we oftentimes want to know about a graph, whether that graph is a straight line or a circle or a parabola or some other polynomial, is we want to find all of those places where it crosses the x-axis and or all of the places that it might cross the y. When I am looking at my x-axis, if I have a function or a relation or a shape and it has places where it crosses the x-axis, notice that all of these points here, what they have in common is that their y-coordinate is 0. Okay. I've moved left or right. Maybe this is -7 and maybe this is +1 and 14 and 200. But we don't know where we've moved left or right here from my diagram, but we do see that we've not moved any steps up or any steps down. And so our y-coordinate in all of those is 0. In reverse, if I am looking at my y-axis only, and I have a function or a relation that has intersected and crossed that axis, that in this situation, I don't know how high or how low I am to cross there. I don't know if this represents +10 or -1,000. And same with this one, but I can see that I've moved left and right 0 steps. My x-coordinate is 0. So anytime I want to find algebraically where my graph, regardless of what shape it is, crosses the x-axis, I know that happens when y equals 0. And in reverse, I can find all of the y-intercepts by setting the x equal to 0 and solving then for y. Okay. Now, of course, where we start with this idea is oftentimes when we're looking at straight lines. Okay, if I have the equation 2x plus 3y equals 12, if I want to find the x-intercept for that line, I can plug in y equals 0. So 2x plus 3 times 0 equals 12, which says 2x equals 12. So then when I solve for x, I find out x equals 6. Now, when I have you give me the x-intercepts or the y-intercepts for any shape, any relation, any function that we deal with over the semester, I always want it given to me as an ordered pair. Okay, ordered pair, remember, is always the x-coordinate first and then the y-coordinate next. So here I found out the x-coordinate was 6, and the y-coordinate I chose to begin with was 0. Okay. The x-intercept of this line is 6, 0. If I want to find the y-intercept, I know that that happens when x equals 0. And so I can replace the x with the number 0. I can solve for y, 3y equals 12, and find out that y is equal to 4. When I write this as an ordered pair, the 0 is the x-coordinate that I started with, and the 4 is the y-coordinate that I found when I solved. Okay, the y-intercept of this line is 0, 4. The x-intercept is 6, 0. Okay, now algebraically, and depending on which of my classes that you're in when you're watching this, for a straight line, typically there will be one of each, unless that line is a vertical line or a horizontal line, and then it will only have one or the other. Okay, when you have curves like parabolas or circles, other polynomial functions that we'll deal with in college algebra class, you could have many x-intercepts. And if it's a function, if we've used that word yet, then it will only have one y-intercept at most. Okay. So the algebra is what helps lead us to those values. Now, in the chapter or section where we're talking about straight lines specifically, which this equation represents, again, there will be one of each, and there are going to be other ways that we can determine at least one of those intercepts by the form of our equation. Okay, but this algebraic way will work regardless of what shape you're dealing with, regardless of whether it's a function or not a function, whether it has one intercept or whether it has 21 intercepts. You're going to set the opposite letter equal to 0. X-intercepts happen when y is 0. Y-intercepts happen when x is 0. And then once you've replaced that variable with 0, what you're left to solve is something that you should be able to algebraically do at the level that you're in.